2025, the year that will define the future of warfare as robots take center stage. Introduction. The year 2025 is set to mark a pivotal moment in the evolution of warfare driven by remarkable advancements in robotics and artificial intelligence (AI). As technology progresses, the integration of humanoid robots into military operations is expected to redefine combat strategies and capabilities. This report synthesizes insights from various sources to showcase the anticipated changes in warfare, the role of robotics, and the implications for society. Key advancements and technologies. 1. Genesis Project and Nvidia's Cosmos. The Genesis project represents a significant leap in robot training technology, utilizing a generative physics engine to create dynamic training environments. This innovation enables robots to adapt to complex scenarios, enhancing their operational capabilities in military contexts. Nvidia's Cosmos project complements this by utilizing vast amounts of video data to train AI systems, suggesting a future where a single AI can control thousands of robots simultaneously. This could lead to unprecedented levels of coordination in combat situations. 2. Humanoid robots. Projections from Morgan Stanley indicate that the U.S. humanoid robot population could reach 63 million by 2050. This marks a substantial market potential driven by companies like Tesla, Boston Dynamics, and Figure AI. Tesla's Optimus robot aimed at mass adoption is projected to cost around $20,000, making humanoid robots more accessible for various applications including military use. 3. Consumer Electronics Show CES 2025. CES 2025 showcased practical applications of humanoid robots, highlighting their advanced capabilities in human-like interactions. Robots demonstrated facial recognition and contextual conversation, underscoring a shift from theoretical to practical usage in everyday life and potentially military operations. 4. Battery technology. The operational viability of humanoid robots hinges on advancements in battery technology. Solid-state batteries, expected to enhance operational time significantly, could allow robots to function for up to 20 hours on a single charge by 2030. This advancement is crucial for applications in various sectors, including eldercare, logistics, and military operations. Common key points. 2025 is anticipated to be a transformative year that will see the integration of robots into daily life, particularly in military applications. AI is central to enhancing robot capabilities, enabling sophisticated interactions and improved operational efficiency. The potential for humanoid robots extends beyond the battlefield, impacting industries like eldercare, logistics, and manufacturing. Differences between sources. Some sources emphasize technological advancements and market forecasts, while others focus on the broader implications for job markets and workforce dynamics resulting from increased automation. Predictions regarding the number of humanoid robots vary widely, from Elon Musk's ambitious forecast of 10 billion robots by 2040 to more conservative estimates from financial institutions. Implications for warfare. 1. Operational strategies. As robots become integral to military operations, strategies will evolve to leverage their capabilities. The ability to deploy swarms of robots controlled by a single AI could change the dynamics of battlefield engagements, allowing for more strategic and less risky maneuvers. 2. Human-robot collaboration. The integration of humanoid robots into military units will require new paradigms for human-robot collaboration. Training soldiers to work alongside robots effectively will be crucial for maximizing efficiency and minimizing risks. 3. Ethical considerations. The rise of robots in warfare brings forth ethical dilemmas regarding decision-making in combat scenarios. Questions about accountability and the moral implications of using autonomous systems in warfare will necessitate new frameworks and regulations. Timeline of events. 2024, significant advancements in AI and robotics, with the Genesis and Cosmos projects making strides. 2025 Breakthroughs in humanoid robotics showcased at major tech events like CES, indicating a shift towards practical applications in military contexts. 2030 Solid-state batteries expected to become commercially viable, enhancing robotic functionality and operational capacity. 2035 to 2050 Projections of humanoid robots reaching substantial numbers, impacting various industries and military applications. Conclusion: the year 2025 is positioned to be a transformative period for robotics, particularly in warfare. As humanoid robots transition from experimental technologies to essential tools, they will reshape military strategies and operational dynamics. This evolution will also have broader implications for society, necessitating a re-evaluation of workforce skills and ethical considerations related to the deployment of robots in combat. The advancements in robotics and AI signify a new era of warfare where technology plays a central role, fundamentally altering the landscape of conflict and defense. Appendix: Key players in humanoid robotics. 1. Tesla Optimus, aiming for mass market adoption with a target price of $20,000. 2. Boston Dynamics Atlas, focused on industrial tasks, emphasizing agility and reliability. 3. Figure AI's Figure 02, designed for manufacturing, showcasing advanced capabilities. 4. Unitree G1, aimed at research applications with a proposed $16,000 price tag. Future considerations. As we look towards 2025 and beyond, the discourse surrounding robots in warfare and everyday life will continue to evolve. Stakeholders must engage in proactive discussions about the implications of these technologies, focusing on ethical deployment, workforce transitions, and the potential for enhancing human capabilities through collaboration with machines. The future is not just about the technology itself, but about how we adapt our societies to integrate these advancements responsibly and effectively. Counterintuitive information in the content. 1. Job creation versus job displacement. While many narratives surrounding automation and robotics often focus on job displacement, the World Economic Forum report highlights that despite 75 million jobs being displaced by automation, there is an expectation of creating 133 million new roles. This suggests a net positive outcome, which contrasts with the commonly held belief that robots will solely lead to job loss. 2. Scale of robot production. Elon Musk's prediction of 10 billion humanoid robots by 2040 seems extravagant and unrealistic, especially when analyzed against current production capabilities and resource availability. The production estimates reveal that achieving such numbers would require a manufacturing scale far beyond current automotive production, which is counter to the optimistic narrative that robots will become ubiquitous. 3. Humanoid robots in everyday life. The rapid advancements in humanoid robotics showcased at CES 2025 suggest that practical applications are becoming more prevalent, contradicting the perception that humanoid robots are still in the experimental or conceptual phase. The reality is that they are moving towards becoming integral parts of daily life in various sectors much sooner than anticipated. For battery technology's impact, the expectation that solid-state batteries will significantly enhance the operational capabilities of humanoid robots by 2030 challenges the notion that current lithium-ion technology is sufficient for widespread adoption. This presents a more optimistic view of how quickly robots can become functional in everyday applications, contradicting the belief that existing technology is a major bottleneck. 5. Public perception of AI companionship. The overwhelming media attention and public interest in AI companionship as seen during CES 2025 counters the skepticism surrounding the acceptance of humanoid robots in society. The positive reception indicates a shift in public perception, where the focus is more on enhancing human experiences rather than fearing automation. 6. Resource constraints versus economic potential. The discussions around the economic benefits of humanoid robots, including the potential to reduce costs and increase productivity, stand in stark contrast to the daunting resource requirements for mass production. This duality highlights a tension between the optimistic economic forecasts and the practical challenges that could hinder such growth. 7. Diverse predictions on robot numbers. The stark differences in predictions regarding the number of humanoid robots ranging from Elon Musk's 10 billion to Goldman Sachs' 1.4 million by 2035 illustrate a significant uncertainty in the market's future. This undermines the narrative that the rise of humanoid robots is a foregone conclusion and emphasizes the speculative nature of such forecasts. 8. AI integration beyond robotics. The integration of AI across various sectors, including consumer electronics and smart home technologies, indicates that the advancements in AI are not limited to robotics. This contradicts the idea that AI's primary role is in enhancing robotic capabilities, showcasing its broader influence on technology and daily life. 9. Technological convergence and its pace. The rapid convergence of AI advancements, hardware innovation, and battery improvements may suggest an accelerated timeline for the integration of humanoid robots into society. This contrasts with the more cautious forecasts that expect a slower adoption rate due to various barriers. 10. Shift from labor shortages to robot adoption. The narrative around labor shortages driving the need for humanoid robots presents a counterintuitive perspective. While it is often thought that technological advancements would lead to a diminished need for human labor, the reality is that these advancements are seen as solutions to existing workforce gaps rather than replacements for human workers. These counterintuitive insights challenge prevailing assumptions about the future of robotics and AI, indicating a more complex and nuanced landscape than the straightforward narratives often presented. Important content in the report on the future of warfare and robotic integration. The report highlights the year 2025 as a crucial turning point for warfare, marked by the introduction of humanoid robots and advanced artificial intelligence (AI) technologies. While many of the advancements in robotics and AI are well covered, such as the Genesis and Cosmos projects the growth in the humanoid robot population and improvements in battery technology, there are nuanced details and implications that many may overlook. These overlooked aspects are significant because they shape our understanding of how these technologies will impact not only military operations but also social structures, economies, and ethical considerations. 1. Genesis and Cosmos projects, practical implications for military training. The Genesis project's generative physics engine and Nvidia's Cosmos project are pivotal innovations. The report discusses them primarily in the context of AI training for robots. What may be overlooked is how these technologies can alter military training paradigms. The ability to create dynamic training environments and scenarios can lead to more effective and adaptable military strategies. This shift could mean that future soldiers will train alongside robots in real time, creating a new form of collaborative warfare that emphasizes human-machine synergy. Understanding this dynamic is crucial for military strategists as it could redefine operational doctrines and tactics. 2. The economic impact of humanoid robots. The projection of the U.S. humanoid robot population reaching 63 million by 2050, as stated by Morgan Stanley, is often interpreted through a market lens. However, the underlying economic implications, especially regarding labor markets, are significant. The displacement of a substantial workforce in sectors such as eldercare, logistics, and manufacturing raises questions about unemployment and the need for reskilling initiatives. While the report mentions potential new roles created by automation, the scale of displacement and the readiness of educational systems to adapt to these changes are critical points that require attention. The societal ramifications of these shifts could lead to economic inequality and unrest if not managed properly. 3. Battery technology, a barrier to adoption. While advancements in battery technology are discussed, the depth of their implications is worth exploring. The transition from lithium-ion to solid-state batteries promises longer operational times and reduced charging durations, yet the commercialization timeline extends to 2030. This delay underscores a significant bottleneck in the widespread adoption of humanoid robots. If these robots cannot operate effectively due to battery limitations, Their integration into sectors like eldercare and logistics, which are framed as near-term applications, could be significantly hampered. This highlights the need for continued investment in energy solutions and underscores the importance of battery technology as a critical enabler of robotic capabilities. 4. Diverse perspectives on robot population projections. The report presents a range of projections regarding the future population of humanoid robots. Elon Musk's ambitious prediction of 10 billion robots by 2040 contrasts sharply with more conservative estimates from Goldman Sachs and Morgan Stanley. This divergence is not merely about numbers, it reflects differing views on technological feasibility, societal readiness, and market acceptance. The debate around these figures can inform policy discussions and strategic planning as stakeholders assess the readiness of infrastructure resources and societal frameworks to support such a dramatic increase in automated systems. 5. Human-robot interaction at CES 2025. The Consumer Electronics Show CES 2025 showcased humanoid robots with advanced capabilities in human-like interactions such as Robotics Azaria and Engineered Arts Ameca. While the technological advancements are impressive, the implications of these interactions are profound. The ability for robots to maintain eye contact, recognize faces, and engage in contextual conversations raises ethical and psychological questions about companionship, empathy, and the human experience. As robots become more integrated into daily life, the potential for emotional attachment to machines and the redefinition of social relationships warrant careful consideration. 6. Broader economic and social implications. The report hints at a broader economic transformation driven by humanoid robots and AI technologies. The concept of an economy where robots perform a significant proportion of tasks could lead to decreased prices for goods and services, potentially transforming consumer behavior and economic structures. However, this potential utopia comes with risks, including workforce displacement and the need for new socio-economic models that account for a radically changed job landscape. The conversation around universal basic income or alternative economic frameworks to support displaced workers is essential and needs to be part of the discourse surrounding robotics and AI advancements. 7. Regulatory and ethical considerations. As humanoid robots become more prevalent, regulatory frameworks to govern their use will become increasingly necessary. The report touches on the implications of AI in warfare, yet the ethical considerations surrounding humanoid robots in civilian life, particularly related to privacy, security, and human rights, must be addressed. The potential for surveillance and data collection through advanced humanoid robots poses significant challenges that require proactive regulatory measures to protect individual freedoms and societal norms. Conclusion. The year 2025 is set to be transformative for warfare and the integration of humanoid robots into society. However, the implications of these technological advancements extend beyond mere operational efficiencies or economic forecasts. They touch on deeply human concerns, ethical considerations, and the need for societal adaptation. By recognizing and addressing these often overlooked aspects, stakeholders can better prepare for a future where humanoid robots play an integral role in both military and civilian contexts. 1. Technological advancements in robotics and AI. The Genesis and Cosmos projects stand out as pivotal developments in the field of robotics and artificial intelligence. These initiatives are not only enhancing the capabilities of robots but also transforming how they are trained and deployed. The Genesis project focuses on creating dynamic training environments for robots, while Nvidia's Cosmos project utilizes extensive video data to improve AI training. Together, these advancements signify a shift towards more autonomous and capable robotic systems that can operate in complex scenarios, particularly within military applications. 2. Market projections and economic implications. The significant growth in the humanoid robot market, with projections suggesting a rise to 63 million units in the US by 2050, underscores the potential economic impact of robotics. As companies like Tesla and Boston Dynamics invest heavily in humanoid robots, the anticipated decrease in production costs, from around $250,000 to $20,000 per unit, will likely drive widespread adoption. This shift is expected to create not only new job opportunities but also challenges related to workforce displacement, necessitating a re-evaluation of skills and training in the labor market. 3. Impact on various sectors. The integration of humanoid robots is expected to reshape multiple industries, including eldercare, logistics, manufacturing, and construction. With an aging population and labor shortages, humanoid robots could offer solutions by assisting with caregiving tasks, enhancing productivity in warehouses, and performing repetitive or hazardous jobs in manufacturing. This trend highlights the necessity for industries to adapt to new technologies and consider how humanoid robots can complement human labor rather than wholly replace it. For battery technology as a key enabler, advances in battery technology are crucial for the operational viability of humanoid robots. The anticipated commercialization of solid-state batteries promises longer operational times, up to 20 hours per charge, and faster charging capabilities, which are essential for the widespread deployment of robots in various applications. The ongoing improvements in battery efficiency and cost reduction are pivotal factors that will determine the pace at which humanoid robots can be integrated into society, thereby influencing their adoption across different sectors. These points provide a comprehensive overview of the transformative potential of robotics and AI in warfare and other sectors, emphasizing the technological, economic, and operational implications of this evolution. 1. The use of drones in warfare. The integration of drones into military operations has transformed modern warfare, as seen in conflicts such as the U.S. military's use of UAVs, unmanned aerial vehicles, in Afghanistan and Iraq. These drones have allowed for surveillance, reconnaissance, and targeted strikes, changing traditional combat strategies and raising ethical concerns about remote warfare. 2. The development of the atomic bomb. The Manhattan Project during World War II exemplifies how technological advancements can redefine warfare. The successful development and deployment of atomic bombs in Hiroshima and Nagasaki not only ended the war but also ushered in the nuclear age, fundamentally altering global military strategies and international relations. 3. The introduction of tanks in World War I. The Battle of the Somme in 1916 marked the first significant use of tanks in warfare. This innovation provided a solution to the stalemate of trench warfare, demonstrating how technological advancements can create new tactics and strategies on the battlefield, thereby changing the nature of ground combat. Future outlook: 2025 and beyond, the era of robotics in warfare. As we look toward 2025, the landscape of warfare is set to undergo profound transformations, primarily driven by advancements in robotics and artificial intelligence (AI). The integration of humanoid robots into military operations as well as other sectors signals a shift in operational strategies, capabilities, and ethical considerations. Here are several key predictions and insights about the future of warfare as robots take center stage. 1. Increased autonomy in military operations. By 2025, we can expect a significant increase in the autonomy of military robots. Projects like Nvidia's Cosmos and the Genesis initiative are paving the way for robots capable of executing complex tasks with minimal human intervention. This autonomy will not only enhance operational efficiency but also reduce the risk to human soldiers during combat. 2. Enhanced human-robot collaboration. The future of warfare will likely see improved collaboration between human soldiers and robots. With advances in AI, robots will be able to understand and respond to human commands more effectively. This synergy will allow for more complex missions where robots handle logistics and support roles while human soldiers focus on strategic decision-making. 3. Humanoid robots on the battlefield. The emergence of humanoid robots such as those being developed by Tesla and Boston Dynamics will redefine battlefield dynamics. These robots could serve various roles from frontline support to logistical assistance. significantly enhancing the capabilities of armed forces. Their ability to navigate human environments will also enable them to perform tasks in urban warfare scenarios that traditional military vehicles cannot. 4. Ethical and legal challenges. As military robots become more autonomous, ethical and legal challenges will arise. Questions regarding accountability for actions taken by robots in combat, the implications of AI decision-making in life-or-death situations, and the potential for misuse of robotic technology will need to be addressed. International regulations may emerge to manage these challenges and establish frameworks for the responsible use of military robotics. 5. Cybersecurity and robot vulnerabilities. With the rise of robotic warfare, cybersecurity will become a critical focus area. As military robots increasingly rely on AI and network systems, they will be vulnerable to hacking and cyber attacks. Ensuring the security of these systems will be paramount to maintaining operational integrity and preventing adversaries from exploiting vulnerabilities. 6. Training and simulation advances. The integration of sophisticated robotics into military operations will necessitate advanced training programs for soldiers. The Genesis Project's generative physics engines will allow for immersive training environments where soldiers can practice alongside robots in simulated combat scenarios. This will improve preparedness and adaptability in real-world situations. 7. Impact on global military dynamics. The proliferation of robotics in warfare may alter global military dynamics. Nations that lead in robotics and AI technology will likely gain strategic advantages, influencing power balances and military alliances. Countries lagging in these technologies may face existential threats, prompting a new arms race focused on robotic capabilities. 8. Public perception and acceptance. Public acceptance of robots in warfare will play a crucial role in their integration. As robots become commonplace in military operations, societal attitudes will evolve. The portrayal of robotic soldiers in media and public discourse will shape perceptions, potentially leading to greater acceptance or resistance based on ethical concerns and the perceived effectiveness of robots in combat. 9. Diversification of applications. While military applications are a primary focus, the advancements in humanoid robots will also extend to civilian sectors, including elder care, logistics, and manufacturing. The dual-use nature of these technologies suggests that developments in military robotics could lead to innovations that enhance civilian life, further integrating robots into everyday scenarios. 10. Long-term projections beyond 2025. Looking beyond 2025, the trajectory of robotics in warfare suggests a future where robots are an integral part of military strategy, capable of operating independently in complex environments. As technology continues to evolve, the potential for fully autonomous military operations could become a reality, raising new questions about the nature of warfare, the role of human soldiers, and the ethical implications of robotic combatants. Conclusion. The year 2025 is expected to be a watershed moment in the evolution of warfare as robots ascend to a central role in military operations. The implications of this shift will resonate through tactical strategies, ethical considerations, and global military dynamics. As we advance toward this future, the collaboration between humans and machines will redefine the battlefield, necessitating careful consideration of the accompanying challenges and opportunities. The integration of robotics in warfare will not only change how wars are fought but will also challenge our understanding of responsibility, ethics, and the very nature of combat.